The potential for mechanically improving the human body is huge, but there may soon be an even better way to repair or replace damaged body parts. Not with steel and carbon fiber, but with our own flesh and blood. The case of Lee Spivak suggests a possibility that is almost miraculous, and his story sounds like an urban legend. Lee's a skilled model maker who works in a hobby store. One day in 2005, he was talking to a customer about an airplane and had a terrible accident.
I was squatting behind the wing of the airplane, and I raised my hand and pointed to the engine and told the gentleman he needed to get rid of that engine. And doing that, I put my finger through the end of the prop and cut off about a 3/8 to a 1/2 inch of the fingertip.
Normally, an accident like this would mean a trip to the ER and spending the rest of your life with a hacked-off finger. But Lee had an ace up his sleeve. His brother Alan was a research doctor who had spent years working on limb regeneration. He developed an experimental powder, though it had never been used on humans. Lee agreed to try it and had some shipped to him.
To go in, take a shower, let the Band-Aid wash off your hand, and then pat it dry with a completely clean towel. And then I want you, while it's still wet, to pour the powder over the injury, just putting it over the top, and then putting a Band-Aid over it, which is exactly what I did.
After doing this every day for a few weeks, his fingertips started to regrow, even the nail.
My next statement to my brother was, "How will it know when to stop?" And he said, he said, "It'll know." So it did, in 4 weeks, completely regrow.
Coming up, the long-sought power of regeneration may come from a shocking source.
The future
Next. In 2005, a 72-year-old man accidentally cut off his fingertip. A few weeks later, after sprinkling a mysterious powder on it sent to him by his brother, his finger grew back, just the way it was before. Even the nail. I've heard about young kids growing back a fingertip, but never an elderly man. Now, Dr. Stephen Badylak at the University of Pittsburgh is spearheading an investigation into exactly how this magical powder works. He's a pioneer in the field of regenerative medicine. Or, put another way,
I grow body parts.
Hey, it's a living. In fact, it's about life in its early stages and how we might recapture the regenerative powers of the human fetus. When we're in the womb, if we lose a limb, it just grows back. That's because before we're born, every cell in our body has the potential to become part of any organ or any limb.
It's rather remarkable, isn't it, that within 9 months we can start with a single cell and form a complex entire human being. And so, in essence, what we would like to do is to temporarily and locally make the body think that it's a fetus again, just at the injured part. Just regrow it rather than respond to injury.
We don't know why we lose the power of regeneration once we're born. Newts and salamanders can grow back legs their entire lives. Badylak thinks humans should be able to do the same. It's just a matter of sending our cells the right instructions.
Our job is to try to figure out those signals that occurred or were turned on when we were developing fetus and say, what happened to them? Why did they get shut down?
We follow all sorts of signals in our daily life. Green says go, red says stop, yellow says hurry up. It's gonna turn red. When we injure ourselves, the body sends out signals to reroute its activities to start the healing. And though he can't yet read the signals, Badylak believes they come from chemicals floating around in the soup between the cells, something called the extracellular matrix.
The extracellular matrix for a long time was considered to be nothing more than the glue that held cells together. But in the past 20 years, we've learned that it's an information highway between cells that can tell cells, for example, you should be dividing, or you should be migrating, or you should be differentiating into a piece of bone or a piece of muscle.
And here's where the mysterious white powder comes in. Lee Spivak's brother made it from the extracellular matrix of pig bladders. That's right. The power to regrow a finger came from a farm animal. There were no actual pig cells in the powder, just the dried extracellular matrix. And when Lee sprinkled it on the wounded end of his finger, bam, it turned back into soup. So maybe, just maybe, that pig soup generates growth signals for the cells, the same way blood does when we cut ourselves. If I cut my finger, blood seeps into the wound, creating an environment full of signals telling cells to regrow. But if a cut goes really deep, the body can't fill the entire hole with blood. No matrix, no signals, no regrowth. All that's left is a big scar. But if you apply dried matrix materials from a pig, it creates a thin layer filled with signals that tell the cells to grow back. Day by day, one thin layer at a time, the finger heals itself. That's what Lee Spivak's brother discovered.
He found out by taking the third layer of a pig's bladder, processing it, taking all the cells out of it, the pig cells out of it, this material would actually entice the body to regrow tissue and organs and so on.
Here in Badilac's lab, researchers continue to work with pig bladders. Pigs are the most similar to humans of all domesticated animals, and the bladder is easy to shape into large sheets.
We can either use the entire sheet to cover wounds, we can make a powdered form out of it that fits well for uses where we want to cover an irregularly shaped wound.
What I want to know is, could we use this stuff to grow more than just fingertips?
So I think even major body parts that are lost, like a hand, we will learn how to regrow functional heart tissue, I'm convinced. I think these are within the foreseeable future. I'm an optimist, but also a realist, and I think the future is very bright.
We're always coming up with new ways to upgrade our bodies, making us faster, stronger, and more adaptable. Now, from the inside out, we can keep cool, work out longer, and recover more quickly. We can manipulate our genes to unlock muscle growth potential. We can regrow missing limbs. Or we can approach things from the outside in, replace those missing limbs with metal and microchips. We can wear technology which adds a sixth sense layer of information directly to our bodies, even to our eyes. In the future, we'll all be a bit more superhuman.